Solutions for quiz 5 for math 243. What are we sampling distributions here? So suppose the hair length for whatever. I have data and it's right skewed and the average of the population of the parent distribution is 10 and the standard deviation is 4. This is for the parent distribution, that's important. This 10 right here is mu and this 4 right here is sigma. And it's right skewed. Don't worry, that's not a problem. Determine / justify the shape, center, and spread. All right, shape, center, spread of the sampling distribution. That's key. We're talking about the shape, center, and spread for the average of a sample of size 50. This right here would be my value of n. That's key. This is kind of a trick question. You look at this and you're like, right skewed must be the shape. It's not. That's the shape of the parent distribution. For the sampling distribution, the shape is approximately normal. Why is that true? It's because my value of n, 50 in this case, is greater than or equal to 30. The central limit theorem tells me that if n is large enough, the shape, regardless of the shape of the parent distribution, the shape becomes approximately normal. Center. The center of, let's see, what should I write here? Well, the center of the sampling distribution, the population average of these sample averages, kind of the average of the average, is just equal to mu. And mu was given to me to be 10. The spread, however, the standard deviation of these sample averages, is not just sigma. It's sigma divided by the square root of n. So sigma was given to me as 4, and n was given to me as 50. So my spread is 4 divided by the square root of 50. Determine the probability that, you see probability that, you're thinking normal CDF. Probability that what? That the sample average of these 50 is greater than 9. So you go and draw your picture. How do you know what kind of picture to draw? Well, we figured out up here that it's approximately normal, that the center is 10, and the spread is this number. So what it wants is the probability that my sample average is greater than 9. I don't know, 9 somewhere out here. It doesn't have to be drawn to scale. Greater than 9 would be referring to all this area out here. I can calculate that. I can use the normal CDF function in my calculator. And for the normal CDF function, I have to give it the lower bound, 9 in this case. The upper bound is not given to me, so I'll use E99. The center, 10, and the spread, 4 divided by the square root of 50. If you use 4 here, you're calculating the probability that one single person, one single Oregon female, has, what are we talking, hair length longer than 9 inches. Where the hell that came from. But that's not what we're asked. We're asked the sample average is greater than 9 inches, so this is the spread. Anyways, go and type all that in your calculator. So let's see, I'll use normal CDF. So that's under the distribution menu, second variables. Normal CDF is the second one listed. Then my lower bound is 9. Upper bound was not given, so I'm going to use E99. Center was 10. And the standard deviation is 4 divided by the square root of 50. Hit enter, and it'll calculate this area for me, this probability. It says it's 0.96. Okay. 0.9615 maybe. In other words, 96.15%. All right, moving on. What about the probability that the average hair length in this sample is less than 9.3? If you got 2 right, you probably got 3 right. This is very similar. Still shape, still center, except now I want less than 9.3. So 9.3, somewhere over here, less than, you're talking about this area out here. How do you figure that out? Same way. Normal CDF. I give it a lower bound. I don't have one. Okay, use negative E99. Upper bound, there's that 9.3. Center, still 10. Spread, still 4 over root 50. Type all that into your calculator. I'll cheat a little bit. I'll pull up the last entry and just change it. So it's now negative E99, comma, what do I want? 9.3. Look, right? Negative E99 up to 9.3. The center's 10. The spread is still 4 over root 50. Hit enter. I get that number, 0.1079. In other words, I round 0.1080, or 10.8%. Okay, moving on. Last part. This question's hard. This last one's a little bit different. Shape, still approximately normal. I could still draw that little picture. Center, still 10, no problem. What it's now asking me is how long must hair be? So it's not giving me this 9.3, it's asking me for it. How long must hair be so that the sample average, the sample still being these 50 females, will only exceed this length 5% of the time? There's some length out here. I don't know what it is equal to, but I do know that the probability that we're greater than that value, maybe I'll use x naught as my notation, the probability that we're greater than is given to me to be 5%. Now we got to figure out this value. Well, we can do that. Calculate as a function for figuring that out. It's the inverse norm function. And when you're using the inverse norm function, which is found under distributions, it's the third one on the list, you have to tell it three things. You have to tell it the area below the point in question. I don't know the area below. Well, you kind of do, because the area above it is 5%. So if 5% is above it, then 95% must be below it. Mean and standard deviation, same as they've been. Mean is 10, standard deviation is, 4 over root 50? I hit enter. It'll give me this value. I should have said what I put in there. I gave it the area below, the 0.95, the mean, and the standard deviation. And what it gave me was 10.93. So what that's saying is if the population average is 10 and the population standard deviation is 4, the sample average will only be above 10.93 5% of the time. My x naught value is 10.93. This right here is my answer. That's also the end of the quiz, so I'll stop the video there.